Okay. All right. And the other one I want to do today was we want to find the points of inflection for this function. Now, we need to check what is our domain for this, because this is the square root. So the only values that this is going to work for are going to be between -3 and 3. So we have a restriction on our domain, so we don't need to look everywhere. Okay. But in order to find our points of inflection, we have to take the second derivative of this, and it does get very, very messy. Okay, so I'm going to do y prime. I'm not going to factor till the very end. So the derivative of this is 1 times the 9 minus x squared to the 1/2 power plus x times the, or 1/2 times 9 minus x squared to the -1/2 times -2x. Okay, I'm going to clean this up a little bit before I take a second derivative. So this really equals 9 minus x squared to the 1/2. And then this ends up canceling the 2, but it's minus x squared times 9 minus x squared to the -1/2. So that's the first derivative. So now we need to go take the second derivative of this and find where it equals 0, because that's where we're going to find our points of inflection. Okay, so y double prime is going to equal, and this is going to be 1/2 times 9 minus x squared to the -1/2 times -2x. Okay, that's just the derivative of that term. Okay, now we have a product, and both of these are going to be negative initially. So the derivative of this, I'm going to get -2x times 9 minus x squared to the -1/2. And now I have to have minus x squared. Now I got to do the derivative of the second one, and I get -1/2 times 9 minus x squared to the -3/2 times -2x. Okay. All right. So I'm going to simplify them all before we factor, if there's anything I can't simplify. So this becomes, these cancel, and I get -x times 9 minus x squared to the -1/2. This one becomes -2x times 9 minus x squared to the -1/2. So these both share the same term. But this one, if you look, I have 3 negatives, so we know it's negative. The 2 and the 1/2 are going to cancel, but I now have an x cubed out front. And I also have and then I have a 9 minus x squared to the -3/2. Okay? So we have a lot of different stuff here that we got to take care of. So if I look at everything here, okay, what is common? Well, first of all, I have a -x common to everything. And what is the least of these powers is the -3/2 power. So I'm going to pull that out. Okay. All right. So now what is left is, well, everything is the same here except for I'm down a full power. So it's going to be times 9 minus x squared times 1. Okay. I have everything identical to this except I have it, by the way, these are actually the same term. So you could have combined them together and gotten -3 of them. But so I have plus 2 times 9 minus x squared. And then everything is the same here except I have a plus x squared. So that is what is common, or this is what's common. This is what I get when I when I factor it. You could have combined these to -3x, and then you would have had that here. Okay, so let's clean this up a little bit. So this goes on the top, this goes on the bottom. So I have a -x, and I have a 9 minus x squared to the -3/2. Oh, positive 3/2 on the bottom. Sorry about that. Here, if I multiply this out, I get a 9 and an 18, gives me a 27. I have a -x squared, a -2x squared is -3x squared. Okay, plus an x squared is -2x squared. And we need to find out where that equals 0. But we are only considering it, if you remember, on this interval. Okay, So I get one, it's equal to 0 when x is 0. And that one's pretty obvious. Okay. Then the next one is we have to look at, well, where is this 0? And this interval actually makes it easier because this is not in the interval, but how do I show that? Is it's going to be 2x squared is equal to 27. So x squared is equal to 27 over 2. So x is plus or minus the square root of 27 over 2. Well, you may say, well, how do I know it's not in the interval? All right, well, 27 over 2 is 13.5. So the square root of 13 is between 3 and 4. So it's certainly outside the range. So the negative value is going to be to the left of this. So my only value, so that's not in the interval. So my only possible candidate for a point of inflection is that x equals 0. So I'm going to do y double prime at 0. If I plug in 1, which is in the interval, I get a negative, and I get a positive, and the bottom is always positive. So it is negative, it's negative over here. If I plug in negative 1 here, this becomes positive, this is positive, and we know this is always positive. So since it is continuous at 0, I will get a point of inflection. So I get a point of inflection, or POI, at 0, comma, when I plug 0 all the way back up here in the original equation, I'm going to get 0 also, so I get one there. It doesn't ask us for it, but we know it's concave up from negative 3 to 0, and my reason for that is y double prime is greater than 0. It's concave down from 0 to 3 because y double prime is less than 0. Okay? Oop, yeah, you couldn't see that. All right. So there is my answer to that whole thing. So I wanted you to see that. Hopefully this helps because it was a little bit messy. This is, first of all, the derivative's messy. You could factor it to start. I chose to wait, and I think that made it a little bit easier. You may have realized right off the bat that that was really negative 3x times 9 minus x squared to the 1/2. And that may make your life a lot easier when you're actually factoring that out. So, all right. Have a good day and a good weekend. Go Mustangs.